see if we can finish up section 3. We're going to talk a little bit about domain, given not a graph, but given its equation. I did want to make mention that sometimes there are restrictions on functions. Now, if I don't have this restriction, the graph is this U shape that goes up in both directions forever and ever, called a parabola. But with the restrictions here that x can only be greater than or equal to 0, we look at only kind of the right-hand side, including 0, 0, and then that's shaded in black. Now, if they don't give you a restriction, you have to kind of assume, be careful with assuming, but you have to assume that the domain would be the set of all real numbers such that it makes sense, that when you plug them into the function, you get real numbers. So we have to be very careful to exclude any value of x that makes the denominator of the function equal to 0, because you can't divide by 0. And we also have to exclude any value of x that makes the radicand for an even indexed root, like a square root or a fourth root, that makes the radicand negative, because you can't, it's the square root of a negative number, the fourth root of a negative number is not a real number. Remember, it has to yield a real number. Now my examples that I have here say write the domain of each of the functions in interval notation, and I have 4 examples here, a, b, c, and d. You'll notice that a, c, and d are have like a little red asterisk next to it. When you see that, as I'm going through these lessons, you'll need to know that these are examples of problems that were on the semester exam review. And when you get the semester exam review later on, for those of you that are doing the dual credit, you will notice that these 3 problems are on there. So I'm going to kind of highlight those by putting those stars, so you'll know that those are the types of problems that they expect you to know 100% all the time that for the final exam. So clearly finding the domain of each function in interval notation is something that they consider very important. Now, the first one here, the only thing I really have to worry about is this, because it's a rational function, because it's got the variable in the numerator and the denominator of a fraction, I have to be kind of careful here. Is there anything that could make my denominator equal to 0? Well, x minus 6, my denominator is equal to 0 when x is equal to 6. So I can't have 6 in my domain. I can have 0. It's okay if the numerator is 0. 0 divided by a number is a non-zero number is 0. I just can't divide by 0. So to write my domain here in interval notation, the domain of f would be everything but 6. So it would go from negative infinity to 6, and then from 6 to infinity. Notice how I'm using the parentheses to exclude the number here on the end, and to exclude the 6. Now I have another rational one right here, but my denominator is 5. So even though it looks like a rational function, this is actually a polynomial function. This is 1/5 t squared, and the domain, the implied domain for any polynomial function is the set of all real numbers. So my domain here for g would be all real numbers, from negative infinity to infinity. There we go, that's a little bit better. Now I have another one here that involves a radical, and notice it involves a square root, an even indexed root. So I have to make sure that 16 minus x is greater than or equal to 0, that the radicand cannot be negative. If I add x to both sides, I have 16 is greater than or equal to x, or better yet, I have x is less than or equal to 16. Which means for this to stay greater than or equal to 0, x has to be less than or equal to 16. So the domain of this function k would be 16 on down, or from negative infinity to 16, including 16, because I can't have the square root of 0. The last example, I mentioned this one before when I talked about example b. This is a polynomial function. The domain of any the implied domain of any polynomial function, the domain here of k, I use k twice, is all real numbers. Very important concept in pre-calculus is make sure that you can look at the function, the rule for the function written in an equation, and determine its domain. It's much more difficult to find the range unless you have a basic idea of what the graphs look like. That's why it was much easier, given a graph, to find the domain and the range. Here they're just asking for the domain. But you can ask for all sorts of things given a graph. And I have an example here. I have a function f that's graphed out here. It's a piecewise defined function. It's got, looks like 3 parts to it. Notice, open circle right there. And I'm asking for you to find a variety of different things based on this graph. For example, I'm trying to find f of negative 2. Well, f of negative 2, you're asking to find the y value when x is negative 2. Well, it'd be positive 1. F of 4, well, f of 4 doesn't exist because it's not defined. So it does not exist, DNE. Now it's asking for a little bit of a trick here. Find all the x values for which f of x is equal to 3. Now, because I didn't use graph paper, this is going to be a little bit trickier because you have to kind of estimate here when x is 3, when f of x is 3, when the y is 3. Well, the y is 3 on this horizontal line. So that's a little bit off there as far as my graph being exact because I freehanded it and did not use graph paper, but it appears to be, this occurs, at negative 4. So, up here, find all x for which f of x is 3 when x is negative 4. Find all values for x when x is 1. Well, here we go. For when x is 1, that's all these values here between negative 1 and negative 3. So in this case, x would be an element of the set from negative 3 to negative 1. That using, again, interval notation. Now I'm asking for you to find any x-intercepts, if there are any x-intercepts, and of course that's where it crosses the x-axis, and that occurs right here at the origin. So the x-intercept is when the y is equal to 0, in this case x is equal to 0, we'll write it as 0, 0. Now it implies there can be more than one x-intercept, and there can for functions, but there can only be at most one y-intercept if it's a function. Otherwise it would fail the vertical line test. And this again occurs at 0, 0. So not only is it the x-intercept, it's also the y-intercept. Now it's asking for the domain and the range of f. We did this before. The domain of f would be those x values. Get those lights shining above and below. And it would be from 4 and smaller, not including the 4. So the domain here of f would be from negative infinity to 4, but not including the 4. The range, put your lights on the side now and see how it shines. And again, this is over here at negative 4. It does not include the negative 4, but it would cast that shadow. And this goes up and up and up forever and ever and ever. So it looks like from negative 4 on up, but not including the negative 4. So the range of f would be from negative 4 to infinity. This is a key concept, and hopefully there was no Janine Mitchell distracting you, and you take the time to practice, practice, practice.